Okay, so now I'm going to discuss another problem in backpropagation, which is known as the weight transport problem, and it goes as follows. So let's say that you have these three layers, and you have like the error signal del L plus 1 at this particular layer, and you want to know the error signal at this particular layer del L. So if you look at like the equation of backpropagation, it says that the the error signal at layer L is basically the transpose of the weights of the higher layer times like the gradient signal at the lower layer. And in this case, like this is like really problematic because it is not clear that, so you are essentially taking like the transpose, you're taking like the transpose of the higher level weights, and it's not clear like the brain actually does this kind of transpose to deliver like this error signal to the lower layer. And that's why like this type of activity, this kind of thing does not work. So this is like a key problem in backpropagation, which is known as the weight transport problem. And what it essentially says is that to compute like the error signal at a given layer, you need to multiply it by the weight matrix of the higher layer times like the error signal at the higher layer, and there is no way to compute this transpose in the brain. So there should be like another way to deliver like this error signal, which does not involve taking the weight transpose. And in target propagation, essentially you can use like the top-down neural network to deliver the error signal, and the way it goes is similar to like the figure which I showed earlier. So let me go to that. Just wait a moment. Okay, so in this case, like the idea is pretty simple. So let's say that you are looking at this figure. So let's say you are looking at this figure, and what you wanna, let me clear this up. So let's say you're looking at this figure, and you are looking at like this second layer neuron, and after like you have funneled your activity back in. So like you had xi, you had like, you computed this yi, you computed the difference with target, which you call delta yij, and then once you use like the top down neural network to feed back the activity in, you get like this new activity which is delta yi, and this delta yi is essentially the error signal at this particular layer. So now for all the neurons which are like present before this, you can assume that you can feed in like this new kind of del yi back to these neurons to compute like the new error signals at these layers. So in this case, like you don't do actual weight transpose, but you are using like the top down neural network to deliver like these error signals, and that is essentially taking care of the weight transpose problem. Okay, and that's all. So now I will also talk about like some new kind of neurons which are appearing into like our literature and why they are important, and they are essentially the replacement for Macaulay-Pitts neuron, and that's like a pretty cool idea, and it seems to be very fundamental. So we'll talk about that next.